Rahim. Dear students, grade 12, lecture number 55, and we are continuing chapter number 19. Chapter number 19, and the last time we completed the preparations of aldehydes and ketones. Now we are going to start the reactivity of the carbonyl groups, aldehydes and ketones, grade 12. And lecture number 55. We know that aldehyde and ketones are reactive. They are polar. They have the carbonyl groups, partial positive charge and partial negative. This is the carbonyl group, and this is the sigma bond, and one is pi bond. Sigma bond is there and pi bond is there. It is a polar in nature. The oxygen atom has a partial negative charge on it and carbon has a partial positive. So due to the difference of electronegativity, so carbonyl group is a polar. The pi-electron cloud is pulled more strongly by the oxygen atom than carbon. So there is a unequal distribution of electron pairs between the carbon and oxygen atoms. It makes oxygen atom as a nucleophile. Negative charge is a nucleophile. Carbon, partial positive charge, become electrophile. So oxygen acts as a nucleophile and carbon acts as a electrophile. So there are two types of reactions. Number one is base catalyzed nucleophilic addition reactions. Base catalyzed nucleophilic addition reaction. And number two is acid catalyzed nucleophilic addition reaction. So there are two reactions are given here. It's an important topic. Acid catalyzed and base catalyzed nucleophilic addition reactions. So when you are going to start the nucleophilic addition reactions, either acid catalyzed or the base catalyzed, you will get the same product. Just I am going to write the general reaction mechanism of the base catalyzed nucleophilic addition reaction. So this is the base, hydroxyl group acts as a catalyst plus reagent. This is a nucleophile, and get the powerful nucleophile here, and the water is going to be formed. This is a nucleophile. So after getting nucleophiles, it is going to be attack the carbon of carbonyl group. This is the carbon electrophile carbon. This is electrophile carbon, and nucleophile always attack the electrophile, so you will get the intermediate product. Valency of oxygen is not satisfied. Negative charge is created on the oxygen because the valency is not satisfied. Then this nucleophile you will get this product, and base is going to be removed. A base catalyzed nucleophilic addition reaction takes place with a strong nucleophile. So we prepare a strong nucleophile, we make a strong nucleophile from the compound, and this is a base catalyst. So you will get this is a nucleophile which is a stronger one, and this is going to be attacked to the carbon substrate electrophile. Intermediate is going to be formed ion which is a negative charge, and the valency of oxygen is not satisfied. Then there is the water. Bonding is between the hydrogen and hydroxyl is going to be broken down. This oxygen is going to be attached here to make a OH, and the base hydroxyl is going to be removed. The base reacts with the reagent, generates the nucleophile. Already I told you. The addition is initiated by the attack of nucleophile on the carbon, which is electrophile of the carbonyl group. So this is the general mechanism for this. So in your reduced syllabus, aldehydes and ketones, chapter number 19.41, ozonolysis of alkenes. Nineteen point four. Yes, there is the 19.4. Preparation of aldehydes and ketones. We done this. Now nucleophilic addition reactions. Base catalyzed reaction with hydrogen cyanide. Reaction with hydrogen cyanide. This is article number 19.51. 19.51, yes, addition of hydrogen cyanide. So dear students, addition of hydrogen cyanide, page number 219. Hydrogen cyanide adds aldehyde and ketone to form cyanohydrins. The acid generates hydrogen cyanide, sodium cyanide and HCl. So I am going to write a chemical reaction here. It is the same one. This is the same. So only chemical reaction. This mechanism you must write this one. So you have formaldehyde, acetaldehyde, ketones. This is a formaldehyde. Hydrocyanic acid is a highly unstable. It is highly unstable. So we have to prepare at that time by the reactions of sodium cyanide with HCl. So when sodium cyanide reacts with hydrochloric acid, you will get a hydrogen cyanide. So what happens? This hydrogen will combine a hydrogen, oxygen to make OH, double bond remove, cyanide. So this is called cyanohydrin. Cyanohydrin. Formaldehyde cyanohydrin is going to be formed. So if you write acetone, put alkyl groups in the state of hydrogen. This is the propanone, acetone, hydrocyanic acid. Hydrocyanic acid is prepared from sodium cyanide with the HCl. So you will get acetone cyanohydrin. Acetone cyanohydrin. Acetone cyanohydrins are going to be formed here. So the same as acetaldehyde, also you can see the chemical reactions on page number 220. Mechanism already I told you for this one. In the state of the nucleophile, only the put hydrogen cyanide. So this is the same as I explained earlier. Then second number are condensation reactions. Condensation reactions number 4. After this, we are talking about aldehydes and ketones. And now condensation reactions. Base catalyzed nucleophilic addition reaction. This is a very important reaction. Condensation reactions are very important. The reaction in which two molecules of same or different compounds, same aldehyde, different aldehydes, aldehydes and ketone, two molecules. Acetaldehyde, 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 propylaldehyde, aldehyde and ketone, two different ketones also. One thing I will explain. Combine to form a new compound with or without elimination of small molecule like water or ammonia are called condensation reactions. So mostly water is going to be removed from here, we will do here. Reactions in which two molecules of same or different carbonyl groups combine to form a new compound with or without elimination of small molecule like water or ammonia are called condensation reactions. Especially we will use here aldol or ketone aldol or ketone condensation. Ald means aldehyde, old for alcohol. After condensation, after reaction taking place between the aldehydes same or different or ketone same or different, so you will get aldehyde ketone or ketone or aldehyde. Aldehyde and alcohol or ketone or alcohol. That's why I write two, aldol and ketone condensation. So in the aldol condensation I told you, reaction in which two molecules of same or different aldehydes of the different carbonyl groups, same carbonyl groups, and there is one very important thing. There must be alpha hydrogen in the carbonyl group, aldehyde or ketone, both. There must be alpha hydrogen. If there is no alpha hydrogen, there will be no condensation. Remember this one. Aldol condensation is a reaction in which the two molecules of same or different carbonyl, maybe aldehyde groups or ketone groups, compound containing alpha hydrogen. I will explain. What's alpha hydrogen? The hydrogen attached to the carbon atom next to the carbonyl group. Like this one. This is the carbonyl group, aldehyde, maybe ketone, maybe aldehyde. If I am writing this, then I will explain the reaction. Dear students, this is the aldehyde group, functional group. This is the carbon of the functional group, and this is a hydrogen attached. The condition is that in the bracket is written hydrogen attached to the carbon atom next to the carbonyl group. This is the primary condition. This is the carbonyl functional group. After carbonyl functional group, this carbon, there must be another carbon. And that carbon must attach the hydrogen. So there is no carbon. It means that there is no alpha hydrogen. This is not alpha hydrogen. There must be carbon here, like this. This is the alpha carbon. This is the carbonyl carbon. Next carbon is alpha carbon, and these hydrogen attached are called alpha hydrogens. So these are the alpha hydrogen, this is beta carbon. This is a functional group carbon, and this is the next carbon. This carbon contains these hydrogens are called alpha carbons. So there is no alpha carbon, so there is no alpha hydrogen. In this case, here if you write, suppose there are three alkyl groups are attached, like this one. This carbon has a carbon, again no hydrogen. Alpha carbon is there but no alpha hydrogen. Alpha carbon must attach at least one hydrogen atom is called alpha hydrogen. So remember this is very important. If there is no alpha hydrogen, there will be no condensation reactions. Remember this. Combine together to form aldol or ketone, depending upon the carbonyl group you used. And usually during the condensation, one water molecule is going to be removed, as you done the definition of condensation reactions. This is one condition. The carbonyl group must contain alpha carbon. This is number one. Second condition is a mild alkaline solution. Dilute sodium carbonate, sodium bicarbonate, sodium hydroxide. You can use mild alkaline solution must be used. Presence of sodium carbonate, sodium bicarbonate, barium hydroxide, dilute sodium hydroxide can be used with a low concentration. Okay, so this is the phenomena of aldol condensation. Now I am going to explain the type reaction. Number one. Dear students, I am going to explain the condensation of two identical aldehydes containing alpha carbon. Identical, same. Condensation between same aldehydes. This is aldehyde group. Write like this, what I am writing here. Leave this space, aldehyde and this alpha carbon. And this is alpha carbon. And all the three are alpha hydrogens, alpha hydrogen, alpha hydrogen, alpha hydrogen. These. So you can utilize this because this is away from here. And conditions: dilute, base. Dilute, base you can use as a condition. So this is very simple. If you understand, this is the alpha hydrogen, and this is the nucleophile of the carbonyl group. So this nucleophile attached to this hydrogen of the alpha carbon. This hydrogen is going to be attached here. So when it is going to be attached here, CH3, this is a C, and if hydrogen, alpha hydrogen is attached here, and there is a hydrogen here, so the valency of this carbon is not satisfied. One bond, second bond, third bond. And when the hydrogen is removed from here, valency of this carbon is not satisfied. So I leave blank because this carbon and carbon, they are going to join with each other. These carbon atoms join with each other. So this is the aldol. This is the aldol. Aldehyde or alcohol. There is a aldehyde, there is a alcohol. So this is the aldol. According to the IUPAC name, 1, 2, 3, 4. So 3 hydroxy or 3 ol you can write, and butanol. Or this is the alpha carbon. Don't take alpha carbon. This is no alpha carbon. This is the functional group carbon. This is alpha carbon. This is beta carbon. Beta hydroxy butyraldehyde. Beta hydroxy butyraldehyde. So this is the aldol. Then there is a condensation. Aldol condensation. Two names. So in the condensation reactions, write the aldol again. This is the aldol. In presence of HCl, acidic heat, there will be a condensation, means removal of small molecule. Again, there is a use of the alpha carbon. Again, alpha carbon participate. This is alpha carbon, hydrogen, and OH alcohol. They remove the water, and you will get alkene. This is the crotonoldehyde. If you see your book, they are written here, crotonoldehyde. Yes, crotonoldehyde are 2-butene, butene L. 1, 2, 3. 2-butenal or crotonoldehyde. Crotonaldehyde. So this is the condensed product, and this is the aldol product. Combined we call aldol condensation between the two identical aldehydes. This is a reaction between two identical aldehydes, same aldehydes. You can use propanol and ethanol and propanol, but mind it, the alpha carbon must have the hydrogen. If there is no alpha carbon, or if there is a alpha carbon and there is no alpha hydrogen, again there will be no chemical reactions. So dear students, here between the identical aldehydes, different aldehydes, between aldehyde and ketone, and between the two identical ketones. So one reaction I am going to give you between the two ketones. And these two ketones may be similar, may be different. Suppose I am going to do the condensation between the two different ketones. So different ketones. This is the propanol, acetone. This is the functional group. This is also alpha carbon. This is the alpha dash carbon. Two alpha carbon. Functional group carbon. Attached next carbon is called alpha carbon. This is alpha carbon. This is also alpha carbon. Dear students, I am this writing, way of writing. Don't mistake. Because only the alpha carbon is utilized here. So I am writing like this. You must write in this way that you are not going to make the mistake. Most of the students, they make mistake. Must write the conditions. This is the ketone functional group. This is the alpha carbon attached to the next. This is also alpha carbon, alpha dash. Okay. So I put the beta down. If I write straight here, the students they use this hydrogen from the beta. Wrong. That's why I make a branch. Only the alpha hydrogen is going to be utilized. This is alpha hydrogen. This is alpha hydrogen, and there is no alpha beta. So two alpha hydrogens are here. One of them you can utilize here, like this one. Very clear. This can be used, but this away from here. You can interchange. You can put propanol here, and you can butane in here. You can put butane in here, or you can put propanol. This is a butanol. Two butanol. 1, 2, 3, 4 carbon. 2 butanol. So, CSP set. This is the C, and this alpha carbon attached. Make OH. There is a branch, alkyl group like this. Velocity of carbons not satisfied. Hydrogen is gone. Alpha carbon attached there. This alpha carbon is still there, the one hydrogen, and there is a branch. And you have a functional group. After the functional group, there is a alkyl group. So this is a ketone. Ketone, because the ketone is there. This is a ketone and alcohol. Ketone and alcohol. So starting from here, 1, 2, 3, 4, 5. There are 5 carbon atoms and 3, 4 dimethyl or so पहले होंगे because of the alcohol O. That's why before you have to write 4 ol or 4 hydroxy. It's your choice. 4 ol or 4 hydroxy. 3, 4 dimethyl. Then 2 pentanone. 4 ol or 4 hydroxy 3,4 dimethyl pentanone. This is the ketone. Then condensation. Condensation. From here, this is going to be removed. Condensation, functional group, dilute, HCl, heat, CH3, double bond is here. So this is the alkene. 1, 2, 3, 4, 5. 3 in, 3 in, 3, 4 dimethyl 2 pentanone. 3 in 3, 4 dimethyl 2 pentanone. This is the condensed product. Dear students, these are the condensation reactions. Aldol condensation and ketone condensation. Now here, mechanism. These are the very important topics are reduced. That's why you must remember all the topics with the Ministry of Education added in your syllabus. Must remember mechanism of aldol condensation. Mechanism reactions. Following steps are involved in aldol condensation. We are doing base catalyzed nucleophilic addition reaction. This is a base. This is a base, and we are going to write a simple aldehyde which contains alpha carbon. This is a simple aldehyde, ethanol, and this is the alpha carbon. So in the first step, this hydroxyl group nucleophile attached with the hydrogen from the carbonyl compound, which is called acetaldehyde. So in this case, you will get water and this carbon. This carbon contains only remaining 2 hydrogen atoms, and there is a functional group. Negative charge is created on the carbon atom. So this is the first step. Attach nucleophile on carbon atom to the alkoxide. This is the alkoxide. So we use the 2 molecules same for the aldehydes in the aldol condensation, 2 molecules. So this is the second molecule. 1. This is the aldehyde group and carbon which has a negative charge. oxygen. This is like this one. So this is the carbon attack here, and this bond is going to be broken down. Bonds are going to be mostly when we write the mechanism reactions. These mechanism reactions are mostly reversible. Mechanism, when you show the mechanism, these are mostly reversible. So this is CH3. This is CH3, and then the C double bond is removed. So there is a charge, hydrogen is there, carbon are attached, valency of this carbon is satisfied, and this is the aldehyde functional group. So this is step number 2. Step number 2. In the step number 3, water we make in the first step. Like this one. So this hydrogen is going to attach to make the aldol. This is the aldol. Formation of aldol, and base is removed. You get, this is the mechanism of condensation reactions. Mechanism of the condensation reactions, again I am telling you. This is the base, catalyzed base. This is the aldehyde which contains alpha carbon, alpha hydrogen. One alpha hydrogen combined to OH to make water. Valency of carbon is not satisfied, negative charge creates. Another aldehyde, because two aldehydes use always. This carbon is nucleophile attached to this carbon. This bond is removed, negative charge is created, valency of this oxygen is not satisfied. CH3, CH, this is the oxygen which has a negative charge. CH2, and this is the aldehyde. Then water which is removed, the hydrogen proton is added to this oxygen to make the alcohol group. Valency of this carbon is satisfied, this carbon is satisfied, aldehyde is there, and the catalyst is removed. So these reactions are called aldol condensations. Aldol condensations. Then also there is a very easy for you one chemical reaction they skipped. Candice reactions they skipped. So inshallah in the next lecture I will explain the haloform acid catalyzed 2,4-D and pH. 2,4-D and pH in the next lecture, inshallah, I will explain this one. So thank you very much. We completed here. You have to see very well.